Hello and welcome to Sterling and VMware's Power Block session. I am Megan Moore, Sterling's VMware Partner Business Manager. We know your time is valuable, so we want to say thank you for choosing to spend a portion of your day with Sterling and VMware. Before we dive into the demo, I want to give you a brief overview of Sterling's capabilities. Sterling is a principal VMware partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we are sure to provide you with the industry best value on all of your client to cloud IT needs. As you can see from this slide, Sterling holds many VMware competencies, including 2 master services competencies and more coming soon. Next slide. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal, state, and local government contracts and support all industry verticals. Security is of the utmost importance at Sterling. We have a robust, secure supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email aliases that you will find at the end of the demo. For questions during the demo, please put them into the Q&A feature at the bottom of your screen, and we will address them at the end. Now, I will turn it over to Cloud Architect Billy Downing to demonstrate managing Tanzu Kubernetes Grid Cluster using Tanzu Mission Control.
Awesome. Thank you, Megan, for the introduction. So my name is Billy Downing. I'm a cloud architect here at Sterling in our strategic services organization. And what we're going to talk about today is Tanzu Mission Control and how that relates in the VMware Tanzu portfolio and how we can use it to manage several Kubernetes clusters across disparate clouds, as well as on-prem in vSphere with Tanzu. So first, we'll talk about a little bit of the background of what the use case of Tanzu is and how it's positioned in the actual portfolio itself, meaning Tanzu Mission Control and where it sits. Then we'll talk about the architecture of TMC, kind of where is it actually existing, what sort of an application is, and what kind of things can it manage. And then finally, we'll talk about a big part of Tanzu Mission Control is how to invoke policy on clusters across environments. We'll get into what that means as we go into the demo. But we're just going to talk about what that organization looks like and how you can best utilize that for your organization if you're trying to figure out how to wrangle together disparate Kubernetes clusters across multiple environments. So the first step is talking about what is TMC. I want to make sure that everybody's on the same page before we just dive into some sort of a product or a solution without actually knowing what problem is it trying to solve. So first, to understand TMC use case, let's look at some of the other aspects of the Tanzu portfolio, and specifically we'll look at Tanzu Kubernetes Grid, which is used for that application runtime for your workloads on Kubernetes. So what Kubernetes is actually doing in this is providing an abstracted platform layer to allow you to run applications across any environment that supports Kubernetes. So much like vSphere gave you a common platform across all of your different sites you had to run virtual machines, Kubernetes does the same thing for containerized applications running on the platform. So what this means is it allows you the ability to then sprawl your applications wherever they need based on cost efficiency, data locality, or different feature sets based on the different environments that you want to run those clusters and therefore your applications. So for example, what does this actually look like? So if we're looking at TMC, it's going to be in that management component of that. So now that we have our applications, they're built out into Kubernetes, they're running as containerized applications, and they're very mobile, and they're very able to run in any environment that we need. So say, for example, we have applications that are running in AWS on Kubernetes clusters. We have applications that are running on-prem in vSphere, and we have applications running in GCP and Azure, or wherever the applications actually may be running. We start getting into a situation where previously, where we were able to try to tackle the problem of treating our applications like cattle rather than pets. Now we're in the situation where we have a bunch of disparate Kubernetes clusters that we're treating like pets rather than like cattle. So what TMC is trying to accomplish here is when you start approaching that area of Kubernetes cluster sprawl, it provides a centralized way to orchestrate all of the control for all of those clusters as a whole. And what that means is being able to develop policy that you can run it as a standard group set across all of your different clusters. So that can be policies such as access control, who can access what, policies such as resource retention, backup policies, as well as where to export logs. For example, we're going to look at how we can do that with Wavefront. And we're going to take a look at what those tools look like specifically in the demo, but I just kind of want to set an overview here. So now we kind of have this idea that Tanzu Mission Control is a SaaS-based application that's hosted by VMware. And what it's going to do is give you one orchestration window to go ahead and take care of all the different clusters you have across various environments. So in the example here, we have a few clusters running on vSphere. So that's vSphere with Tanzu. Those can be TKG guest clusters running on top of your existing vSphere environment today. We have our AWS clusters that are running, in a totally different environment that require, some different handling as far as how you dictate node counts or resources and things like that. And we also have some other clusters that are, perhaps OpenShift or any vanilla CNCF certified Kubernetes distribution can also be attached to TMC for control and management. So what does this mean exactly? I mean, you might be in a situation where you have multiple sites that need to house your application. Due to all your applications running in Kubernetes, this is a pretty easy way to spread your applications across. But again, we face that same problem where now our applications are distributed across and easily managed by the local control planes of Kubernetes, but we don't have a central way of actually controlling the clusters of which they run. So what that might mean, whatever the case is, a TMC comes in to centralize all of the management for those platforms and to ensure standard policy or security, access, provisioning, and so forth is built out through your environment, all through automation and centralization through TMC. So think about that in a simple scenario where perhaps you aren't using any public clouds yet, but you have 4 physical sites all running vSphere with Tanzu. Each one of these sites hosts a certain aspect of your application. You have it spread across all for production, or maybe one site is for development, one site's for DR. In any instance, TMC is used to roll up all of the management clusters from those 4 sites and use them all as cloud endpoints to build command and control over each cluster across multiple regions, or however you break up all of your sites. So for example, if you have 12 clusters across your sites and you need to suddenly provision access to 100 developers, each having their own specific namespaces they can work in or other specific metrics they need as a part of their application, it gets really daunting to think about that as it gets down to the granular level to invoke all of those different policies on each individual cluster as you go on. Of course, you can script those, but I think that is merely, that's kind of like a band-aid to the actual solution of figuring a way to intelligently orchestrate the control of the environment itself. So what TMC is going to allow you to do is organize your different clusters into different cluster object groups to allow us to have different types of security policy or management policy across all of our clusters and create really a hierarchy of open resource management for everything that we have across all of our sites. So what we have here is different types of groups that we can build out for our environment. So for example, if we look on the left, we have cluster groups. Cluster groups are probably going to be focused more on your operations folks, as those are the individuals that are going to want to be able to manage the clusters themselves. They're not so worried about the applications and how they're being developed and where they're actually being deployed. The operations folks are going to be more concerned on lifecycle of the clusters themselves, ensuring correct access is provisioned for the clusters, ensuring backups and exporting of logs is occurring as they'd expect. So you can take all of those clusters across all of your different sites. You can add them into specific cluster groups, whether that be a set of production clusters spread across sites, development clusters, or break it out through application-based clusters across sites, and invoke the same policy based on whatever constraints you need to set forth in your different policy invocation process. If we flip that token over, a developer probably isn't as worried about the cluster lifecycle itself or provisioning access for anybody else. They're more concerned on actually how they can deploy their application to the namespace that they need to be working in. So in that same instance where you have 4 different physical sites, you have maybe 16, 20 clusters that are housing all of your different applications. And each one of those clusters then has different namespaces for different environments for those applications. So say, for example, we have multiple clusters across all of your sites, and we have applications deployed in production, development, and staging namespaces across all of those different sites and clusters across. So what we want to do is be able to provision a common workspace for all of our different developers to have access to the namespaces they need access to without worrying about the cluster specific metrics. So in this instance, we have, say, a production namespace that is built across all of our clusters. We're able to pool all those clusters together and create a workspace for our developers to access the same namespace across all of our clusters without worrying about how are we going to do this individually each time, or having different snowflake type configurations per cluster and namespace access regimens. So kind of to summarize all of that, we're going to look at the actual environment itself, and we're going to create some cluster groups. Then we're going to dictate policy that'll be more focused on our operations folks to pool together the clusters resources to invoke policy there. And then we're going to create workspaces to tie together at the namespace level for our developers to have access to a central place where they can do their work. And with that, I'm going to go ahead and jump into the actual console itself, and then we'll take it from there. So here I am, and I'm right now I'm looking at VMware Cloud Services console. So this is kind of if you're not familiar with VMware Cloud, this is the console that you're confronted with. It's much like, something you would expect to see in AWS console, things like that, where all your services are put out in front. And then you go in and you individually take care of the services that you want to actually use within the VMware Cloud ecosystem. So for this case, we're going to go ahead and take care of VMware Tanzu Mission Control. So we can log into that service. And once we're in here, we can go ahead and see all of the clusters that we have already added to our instance. We can see here that we have several clusters that are across multiple different environments. So we have a vSphere cluster that's deployed on-prem. We have a cluster that is deployed as a GKE cluster in Google Cloud. We have another cluster deployed in DigitalOcean. And then we have finally a cluster that is deployed in AWS. Each one of these clusters are a part of a cluster group so that they can be managed, policy can be determined at the cluster group level rather than each individual cluster. But let's take a look at one of these clusters as a whole. Let's take a look at this AWS development cluster here. So if we take a look at this, what we're able to see in each cluster individually, should we need to dive that deep into a single cluster itself, we can see all the different metrics you'd expect to manage a cluster if they're having issues, quick recaps of resource utilization, different aspects that we can control. We can run inspections on our clusters using Sonobuoy. We can run data protection on our clusters using Valero, which will run backups to our AWS account that we can set up as a destination target. We can also ensure that all of our workloads are running as expected, and we can ensure that our backups and everything like that are all going as we need. So we can manage each cluster as an individual entity, and for some of these specific troubleshooting or things like that. But we can also manage them as groups as well and apply policy at that level. So in this instance, I've created two different groups, and I've kind of categorized my clusters as production clusters versus development clusters. And then this can be in a scenario where you want to do development in the cloud, but you want to run production on-prem or vice versa. This allows you to run, in our case, we have one cluster that's on-prem and we have 3 clusters that are in the cloud. We can go ahead and apply a policy for our production clusters in the cloud to make sure that they all have the same exact policy applied. And conversely, we can have a different policy applied to our development clusters so that our operations admins have access that they need to the cluster that they need whenever they're doing lifecycle management operations or something as simple as backups. Looking at an individual cluster again, I did want to show a little bit about this backup process here. This is what this is actually going to give you the ability to do is completely take the process of backing up your clusters from wherever they exist and target them to wherever you need, be that an AWS bucket in whatever region is most applicable to you. If you have a multi-account type environment, or if you have a central place where you want to store backups, that's something that we can take care of all through this console here. So a use case for this can be something as simple as you have clusters that are deployed on-prem and you want to have an offsite backup solution. You don't want to back up all of your cluster information to a, perhaps you don't have a disaster recovery site, or you don't have the ability to have a separate site provisioned within the same data center. You can use this to actually back up your on-prem Kubernetes cluster into AWS. And then, so do you have a failure scenario, you can then restore that backup using Valero into a new cluster that's deployed elsewhere. So this does give you some sort of a disaster recovery process process with you by backup and restore. And what this is actually going to do is store all these backups directly in AWS. So we know that we're sure our backups are going to be resilient through, the durability of S3. So we offload that SLA for our backups and lifecycle management onto AWS, and we're no longer worrying about where those things are going to exist. This is just an example of doing that backup here. And now if I need to go ahead and restore this to a new one, whether there's an issue with the cluster that I have that I actually backed up this from, or if that site has failed, this will give me a point in time that I can restore to a new location whenever needed. Another aspect that you can do it's quite interesting in these clusters is going ahead and integrating it with something like Tanzu Observability by Wavefront. So what this is actually going to do is automatically integrate your cluster metrics and export them to a place that the data can be analyzed. So in this instance, I'm exporting this at a very high level, so you can go ahead and see exactly the logs that are coming from my cluster to do a little bit more of a granular breakdown of what's going on. We can look at it by namespace, we can look at it by pod, we can look at all the different details within my cluster. So if we're seeing issues with this, again, this is more of an access that an operations person might need, but as well as a developer to see an integrated view from their cluster perspective of how their application is actually performing. So this is just another integration that comes with Tanzu Mission Control that offloads that responsibility from you and gives you a central place to handle a full lifecycle management of your actual clusters. So we talked about the groups. We said we have these two groups here, and those are for the operations folks. So if I look at my development group, I can see all the clusters that I have attached there. And if I look at my production groups, I can see the clusters that are there, and I can apply policy as I see fit. And we'll take a look at what those policies actually entail in just a second. But the second construct that I can go ahead and create are what's called workspaces. Sorry. And what I'm doing with workspaces here is there's no mention of the actual cluster itself. These are all referring to a lot of the namespaces. So in each of my clusters, what I've gone and done is create a specific namespace. And let's go ahead and look at the prod. I've created a specific namespace. So for example, in my DigitalOcean cluster, that's one of my production clusters. I have a namespace that is app a prod. I also have the same namespace created in my GKE cluster, also a part of my production cluster group. And what I can do from here is I can then apply policy specific to my developers. So I'm not worried about giving developers access to specific clusters. I'm worried about giving developers access to the workspaces that they require in order to deploy their applications. So what this allows me to do is if I have a developer that needs to work on the production application, regardless of where it lives, I can attach all the namespaces across all of my environment and then apply policy to give them access to that. Once they have access to that, we can actually look into the workloads that are actually running in this environment. And so I have a few different deployments running in each site. So I have just a very simple Nginx deployment running in both my sites in the same namespace. And this is granted access and control all through a singular policy that we'll look at in just a second. And just as an example of the granularity that you get out of TMC, you get a centralized place to have, you can completely do command and control from this aspect as far as provisioning access, taking care of things, and troubleshooting your applications wherever they exist across your ecosystem. So we've talked a lot about policy and what TMC is doing to centralize that. And I know it's kind of drawing it on, but this is kind of what I'm referring to as far as policy goes. So we separate each one of our clusters, or we build out these different objects and cluster groups as well as workspaces. So like I said previously, cluster is going to be our operations policies, who needs access to the clusters for working on them, for whatever that case may be. And workspaces is going to be a logical aggregation of namespaces, or where are the workloads actually going to exist. And so if we look at this from an access policy perspective, I'm able to individualize each one of these workspaces, and you can see each one of these workspaces which are tied with different actual namespaces across clusters. It doesn't necessarily matter which cluster this is actually coming from. It only matters that this is a part of a workspace. So from a developer perspective, it doesn't necessarily matter where the workspace is going to be or the workloads are going to be located. It matters that they have access to each aspect of that production workspace. So from an access perspective, we can determine exactly who can access this based on groups or user identities that you can link into the VMware Cloud Suite. We can do the same for cluster groups as well. Another security policy that we can apply to have a standardized deployment across our environment is image registry access. So this is at a workspace level. So say, for example, for our production environment, we only want them to be able to access a certain, we'll just use Docker Hub here as an example. But what we're going to do is go ahead and ensure that they're only able to access, Docker registry to pull down their images. And what we can do to do that is just kind of work around with the, let's see. Actually create the policy name that we're going to do and what is the tag for our registry they can access. So we can create a policy that's going to access a specific Docker Hub registry. If we have a local registry using Harbor, we can restrict where the images or the containers are actually being ran from for this workspace based on where they can pull images from. So we can create a policy that invokes, they can only access it through Docker, or they can only access it through a production ready Harbor instance that they know the images there are known good images and scan for security vulnerabilities. Another policy that we can go ahead and apply that is going to be more directly related to the actual security posture of the applications themselves are network policies. For network policies, again, they're broken down by workspaces because this is going to be a workload specific policy for your application. So if we jump in here and we take a look at the application B development environment, we can actually create a cluster network policy rule that we can do to either allow all pods, allow all to pods, or we can deny everything from pod to pod if we have a very secure environment that requires that type of segregation. What TMC allows you to do is, again, as you grow out your clusters and you build out these namespaces to add to these workspaces, for example, this if application B development environment grows in the future, we can simply add those namespaces to this workspace and have this policy automatically inherited by these workspaces themselves. We also have, and I don't want to go into each one of these, but security policies to apply as well as quota policies. And then we can also do custom ones using OPA. But essentially what I'm trying to drive here is that this is giving you the insight to be able to go in and aggregate your resources across all of your different sites and build out different constructs to organize them in a way that you can apply policy in a singular fashion, whether that be for team function or application function. Another aspect of this is actually running inspections on your clusters. And what this is going to do is just be a way to run testing on your clusters themselves to ensure that as they're deployed, if they are deployed by TMC or if not, you can run these tests using Sonobuoy that's going to go and give you a report as to the conformity of the cluster itself. So this can be something that if you're dealing with a situation where you have regulation, conformance policies that you need to have CNCF approved clusters running in your environment that don't have any known vulnerabilities across them. This is a way that you can automate that scanning functionality for your clusters themselves. Here's kind of where I wanted to go into how this integrates with TKG specifically. So if you look at the different accounts that I have located here, I have a production account or a protection account. So this is actually the account that was going to be using for my backups. So I have here 2 different AWS accounts, and what I'm using these to store those S3 buckets and associate TMC to give them the appropriate roles to back up to S3. Let's look at the integrations here. So I do have Tanzu observability set up, as we saw a little bit earlier, to export all my metrics to and integrate directly into the clusters themselves. We don't have this set up, but this is another option, is to set up Tanzu Service Mesh, which is another way to aggregate all of your resources across your sites, to build out a service mesh based on Istio, to interconnect all of your sites through an abstracted tunnel system using a service mesh. So you create an overlay environment so that your clusters workloads are not only working in workspaces that are spread across sites, but they're also networked together to work as a single entity in a distributed architecture. We have our management clusters. And so kind of what I wanted to show here is that benefit you have with, even if you're not in the cloud completely, if you are only a vSphere customer and you're looking at running containerized applications across multiple sites, you will still run into that situation of needing that orchestration layer between your clusters as you build out different Kubernetes environments across even your physical sites that are on-prem. And so what we have here is I have added into this is my Sterling HQ management, which is my supervisor cluster deployed on-prem. And you can see all of my namespaces are brought into my TMC cluster. And using this as a management tool, I can actually look at all the clusters that I have deployed in my on-prem environment. And again, I can manage them. And based on that management, I can lifecycle them. So I can upgrade them when needed. I can back them up when needed. And I can integrate them with Wavefront for telemetry data. And I can also integrate them with Tanzu Service Mesh for interconnected network overlays. So just take a look at what that environment actually looks like. Here is my vSphere environment that is connected to TMC. This is my on-prem environment. And from here, we can see I have all these different namespaces. And each one of these namespaces are essentially a focused area for developers or applications to deploy their work. So based on these different namespaces, I'm able to segregate workload performance or workload management across whatever constructs you might have. So if I have development namespaces, if I have specific namespaces for applications or different use cases, I can take a look at this here. And from here, we can see that I have a few clusters that are actually deployed directly from Tanzu Mission Control. And imagine if you had, multiple sites and you have dozens of namespaces across each one of your sites, and you have clusters deployed in each one of those namespaces. You can quickly run into an issue where you have namespace sprawl or cluster sprawl for your application. And this is where TMC or Tanzu Mission Control comes in as a use case to go ahead and orchestrate the management of all of those into a single pane of glass. This also allows you to give a separation of roles from your vSphere administrators to your Kubernetes administrators, if that's a team dynamic that you have in your organization. But because all these products are created by VMware, they do have a similar UI. So those folks that are trained up on vSphere can deploy vSphere with Tanzu without being Kubernetes experts, and they can jump right into TMC, integrate that cluster into the TMC console, and then go ahead and it creates more of a batteries included type Kubernetes environment for your clusters as they go across different environments. So overall, that's all that I had to present for this. What I wanted to kind of leave you with is Tanzu Mission Control is really a solution to, we've solved the problem of changing our applications from pets into cattle. Using Kubernetes as a platform, a ubiquitous platform across all of our different environments. But we have yet to completely solve that problem of changing each one of our Kubernetes clusters as they sprawl out into cattle as well. Right now, a lot of people are managing them individually, just like their pets. They have unique update patterns. They have unique services on each one of them. And TMC is here just to kind of centralize that performance or centralize that command and control of the clusters across your on-prem or public cloud environments. So I want to thank you with that. And are there any questions that we have?
Hey, Billy, yes, we do have one question. Can TMC integrate with different types of Kubernetes clusters like OpenShift or EKS?
Yes, absolutely. So as we show here, I do have connections into multiple clusters. That's a good question because it actually kind of goes into a point of creating clusters versus attaching clusters. So TMC has two different ways to manage clusters. You can create a cluster directly from TMC, or you can attach a cluster. So TMC has the ability to create clusters in AWS as well as vSphere today. There are other providers on the roadmap going forward. But going through this, I can easily just go ahead and create a cluster. And I'll just go through that process. And we're at one of those namespaces that we just saw in my site. And I won't go through this whole thing, but I can create clusters. And what happens when I create these clusters is I have a little bit of more command and control over them, where I give the options to upgrade them specifically is kind of the big one. If you aren't going to be deploying your clusters into AWS or on a vSphere with Tanzu environment, you can also attach a cluster. And what attaching a cluster is going to do is basically install an agent into your cluster. So what you'll end up doing is you apply the group that you want to put it in. You go next, and then it'll give you a YAML output or a configuration file that you can go ahead and apply in your cluster. And then what this is going to do is create a namespace specific for TMC. And what it's going to do with that is deploy a few pods that are going to act as callback pods into the TMC service. And once those pods are activated and the services are running in your cluster, you'll be able to attach your cluster. So for example, this GKE cluster was not created by Tanzu Mission Control, but I was able to deploy it in GKE using Google Cloud and then attach it to my environment here. And from there, I'm able to then integrate it with Wavefront. I'm able to set up backups to AWS and monitor it just like I can my other clusters, as well as the typical control you would expect that we talked about previously, creating namespaces. So I can go in here and if I want to have a new application deployed or something like that, I can go ahead and come in here and create namespaces. I can then map those namespaces to workspaces and then apply this just like any other cluster in the environment. So hopefully that answered the question.
And then we have one more question of TMC is underneath VMC Cloud Services Council or separate?
Are you asking, are they separate or is it underneath the cluster? Because they are a part of, so if I go back to the VMware Cloud Console services, again, this is like the central jump off point for all VMware Cloud services that are offered today. So if you subscribe to VMC on AWS, your service will show up here and you'll be able to access that from this jump off point. If you are a customer that is using any of these other tools, once you have access to those, they'll show up in your services that you have access to. You would obviously create users and things like that in here and give them roles to manage these different services, just like you would in AWS or any other public cloud, where you would provision roles and what services those roles have access to. In this case, my account has access to Tanzu Mission Control. So I would jump into that from my VMware Cloud Console, which would then let me into the actual Tanzu Mission Control control plane. Hopefully that answered that.
And that is all the questions we have today.
Awesome. Thank you guys so much for attending. I appreciate your time.